All right, guys, this is question number 3 on the January 2017 Common Core Algebra 2 Regents, and this is a pretty simple factoring question. So the question reads, when factored completely, m to the fifth plus m cubed minus 6m is equivalent to what? So we're going to start this with m to the fifth plus m cubed minus 6m. And remember, the first thing we do is GCF factor if possible, and we can definitely take out an m out of all of these. So divide everything out by m and move that m to the outside. We're left with m times m to the fourth plus m squared minus 6. And now this is a little bit tricky because you have to recognize that m to the fourth is really m squared squared. So we can treat this exactly as we would a regular sum product. We can think of this as, say, x squared plus x minus 6, where x is really m squared. So factor this out, and what we get is two numbers that add to 1 and multiply to negative 6, which would be x plus 3 and x minus 2. Well, that's kind of the same thing as m squared plus 3 and m squared minus 2. And we cannot go any further on this because this is not a difference of two perfect squares. So the answer here is going to be choice 4. Now, the interesting thing about this method here, this question, is that the back-solving method won't really work here. Meaning we can't just multiply all three of these out. And the reason for that is that more than one of them will actually be equivalent to this. Let's take a look at choice number 3, for example. If I distribute this back out, I will definitely get m to the fifth plus m cubed minus 6m. The problem here is that it's not factored completely, and the question's requesting that we factor it completely. Choice number 2 would also work. That one actually has this m distributed to this m squared plus 3, but that also is equivalent to it. The only one, in fact, that isn't is choice 1, because we would just get m squared as our first term. So be careful trying to back solve this one. Make sure that you are indeed factored completely. You could also reject choice 2 for not being factored completely because there is a GCF within that. And that GCF is m, so that's not factored completely either. This one's a little bit trickier to spot because you'd have to recognize that this can be factored using trinomial factoring. So our suggestion here is just to go with the standard factoring techniques. It's not ultimately super difficult and probably something worth being mindful of and something that you need to know.